Assalamualaikum. Today we will talk about jackfruit peel powder using X-ray diffraction. Next, let me introduce my group members. My name is Nur Asra and my friend is Intan Batrisha, Mia Tifal and Yogi Cintia Kusuma Ayu. Today, I want to talk about function of X-ray diffraction. X-ray diffraction is a technique used for determining the anatomy and molecular structure of a crystalline material, in which the crystalline structure causes a beam of incident X-ray to diffraction into many specific directions. Powder XRD is actively for the identification of phase by measuring the diffraction angle and intensity of the diffraction beams and comparison the resulting diffraction pattern to a reference database of diffraction data. Jackfruit powder is a newly explored material for reinforcement in thermosets and thermoplastic biocomposite. It is important to understand its physical and thermal properties so that it can be used and approached in various applications. Next, let's talk about how XRD works. First, what are X-rays? X-rays are a type of electromagnetic radiation with very short wavelengths, measured in nanometers. To give you an idea, 1 nanometer is a billionth of meter. Next, let's talk about scattering and interference. When monochromatic X-rays, meaning X-rays with a single wavelength, hit a substance with a structure at the nanometer scale, they scatter. This scattering creates interference, where the waves either combine, called constructive interference, or cancel each other out, called destructive interference, forming patterns of different intensities. This follows something known as Bragg's law. What about crystalline substances? In crystalline material, the atoms are arranged in repeating patterns. When X-rays interact with this structure, they produce unique diffraction patterns due to the regular spacing of atomic planes. So, how does the XRD process work? It starts with generating X-rays from a cathode tube or rotating target. These X-rays are then focused onto a sample. As the X-rays interact with the sample, they scatter and produce a diffraction patterns. By collecting this pattern, we can analyze the structure of the sample. A key concept in XRD is the spacing. This spacing refers to the distances between planes of atoms in the crystal. Each mineral has its own unique set of this spacing, which create distinct diffraction peaks. These peaks can be compared to standard references patterns, allowing us to identify the mineral structure. In summary, XRD is a powerful technique that uses X-ray to reveal the atomic structure of materials by analyzing how they scatter and interfere when they hit a sample. Next, I will walk you through the methodology of XRD. Step 1 is sample preparation. First, the jackfruit skin sample is prepared. The sample is placed in a laboratory oven to remove any water content, ensuring a dry sample for accurate analysis. Once dried, the sample is ground into a fine powder to ensure it's homogeneous. Step 2. After grinding, the powdered sample is carefully placed onto a sample holder, usually a flat glass or metal plate. The powder is then evenly spread across the holder to create a uniform thickness. This step is crucial because an uneven surface can affect the accuracy of the diffraction results. Step 3 is setting up the instrument. The sample holder is placed in the sample stage of the XRD machine. Once the sample is in place, the scan is started. Then the machine will then emit X-rays which interact with the crystalline structure of the sample, producing a diffraction pattern. And finally, the data is analyzed. After the scan is complete, the diffraction pattern is retrieved from the software. The sample is removed and the sample holder is cleaned for future use.
Lastly, the data and observation are recorded for further analysis.
Now, I'll talk about how X-ray crystallography was used to study jackfruit peel powders. In our analysis, we scanned the samples over a 2 theta angles range of 5 degrees to 80 degrees using a scan speed of 4 degrees per minute. The result showed that jackfruit powders is mostly amorphous. This means it doesn't have a clear crystalline structures, which is shown by the continuous X-ray diffraction patterns. Interestingly, jackfruit peels is made up of 85% crystalline region and 15% amorphous region. Crystalline cellulose produce sharp peaks in XRD analysis, while amorphous materials result in bodice patterns. The particle size of the jackfruit peels powders was also measured. The diameters range from 170 nanometers to 446.80 nanometers with an average of 298.54 nanometers. Its length range from 0.839 millimeters to 2.379 millimeters, and the average length is 1.4775 millimeters. This measurement give an average aspect ratio of 5.531. This study aims to understand how X-ray diffraction XRD can help us analyze the atomic and molecular structures of natural materials like jackfruit peels powders. The result confirmed that amorphous nature of the materials with significant peaks in the diffraction patterns indicating the presence of potassium in the samples.
The X-ray diffraction analysis revealed that jackfruit peel powder is predominantly amorphous, as evidenced by its continuous diffraction patterns. The study identified several significant peaks corresponding to specific crystallographic planes and highlighted the structural properties of the powder, including its particle size and aspect ratio. These findings underscore the potential of jackfruit peel powder for innovative application in biocomposites and material science.